Hello everyone, welcome to Engineering Bookshop. So for this video, we're going to solve problems on our Engineering Mechanics Statics textbook. So it is all about Chapter 1, Fundamental Properties of Vectors, wherein triangle law and parallelogram method and also component methods will be discussed here. So I will going to solve problems 1.22 to 1.20. So just keep on watching guys and let's start. So for problems 1.22, again guys, you must have the copy of the textbook so that you will know the problems that I am solving. So for problems 1.22, I am going to solve it using different methods. So as we all know, we can solve this one by using triangle method, parallelogram method, and as well as component method. So for problem 1.22, we need to look up for the resultant B. So first, I'm going to solve it using triangle method. So our given, we have B1 equals to 3 meter per second. So using triangle method, we are just going to connect the tail of B2 to the tip of the B1. So it will be just like this. So B2 is equals to 2 meter per second. And of course, we are going to connect the tail of the resultant B to the tail of B1. And this will be going to be our velocity, our resultant B. And we have given 60 degree here and also 30 degree here. So I will just make it look bigger. So this will be 3 meter per second, 2 meter per second, and B. So as you can see, this is a triangle. So we need to look for the angle of this triangle. So we have here 30 degree, as you can see here. And if this is 30 degree, this will be 30 degree. And then I will assign an angle alpha here, there, and if this is alpha, then therefore this will also be alpha. And if you notice, this is 60 degree. This one is 60 degree. So therefore, this angle will be equal to 60 minus alpha. And this is 30 degree since this one is 60 degree. And since this is 30 degree, therefore this is 30 degree. And of course, this will be 60 degree because 90 minus 30 is 60 degree, and this will become 60 degree. So what are we going to use here to solve for our B? So we are just going to use sine law, wherein it will be just like this. So 3 meter per second, so its opposite angle will be 30 plus alpha, so it will be sine 30 plus alpha equals to opposite is 60 minus alpha, so sine 60 minus alpha equals V sine 90 degrees. So using our calculator, we can solve first for the alpha. So 3 over sine 30 plus alpha equals 2 over sine 60 minus alpha. And of course, we should set the value of x, which is less than 60 degree. So let's say it is about 30, for example. So the angle will be 26.31 degree. So that is not yet our final answer because we are looking for resultant B. So for us to solve for our resultant B, we are just going to use any B is to sine 90, but remember sine 90 is equals to 1. So we are just going to use any of the two. So I will just use this one. So 2 over sine 60 minus A alpha. So our velocity will be 3.61 meter per second. So that's how we solve using triangle method. So how about using parallelogram methods? So we have our given, so the same. So B1 equals 3 meter per second, 60 degree, and B2 equals 2 meter per second. This is 30 degree. So how are we going to create a parallelogram here? So we are just going to mirror this one and this one. So it will be just like this and just like this. So for our resultant B, we are just going to connect here to here. So this will be B. So I will just make it look bigger. So if this is 90 degrees, so therefore this will also be 90 degrees since this is a parallelogram. So this will serve as a diagonal. So for the formula of the diagonal of the parallelogram, b is equals to square root of a squared plus b squared minus 2ab cosine theta. So what will be our a? This will be our a and this will be our b. So this b is also equivalent to the b here, okay? So actually this is also a cosine law, using cosine law. So by substituting, b is equals to square root of 3 squared plus b squared minus 2 times 3 cosine 90. So I am just going to compute it. So square root of 3 squared plus 2 squared minus 2 times 3 cosine 90. So the answer is the same, 3.61 meter per second. So that is how we solve using parallelogram method. And now let's try to solve it using component method. So for component method, we have this formula: r is equal to square root of rx squared plus ry squared, where r is our resultant, rx is the summation of our x component, and ry is the summation of our y component. So for rx, we have 3 cosine 60 plus 2 cosine 30. So for ry, we have 3 sine 60 minus 2 sine 30. So as you can see, this is both positive since our velocity is both in the positive x-axis. And this one, negative 2 sine 30, because this b2 is under negative y-axis. Okay? The ry of b2 is under negative y-axis. So by computing, we have square root of rx, so 3 cosine 60 plus 2 cosine 30 squared plus 3 sine 60 minus 2 sine 30 squared equals, so we have 3.61 meter per second. So it's just the same. So guys, here actually, if you are really observant, you can still solve it on other way. So what is the other way to solve this problem? So this is the simplest way to solve this problem by just using Pythagorean theorem. So as you notice, this triangle is actually a right triangle since this one is a 90 degree. So we can use the formula c squared equals to a squared plus b squared, where c, of course, is the longest leg, which is our resultant b. And a, this is 3 meter per second, and b, 2 meter per second. So by just substituting, we can solve for our b. So it will become 3 square root of 3 squared plus 2 squared. So this is actually the simplest way to solve this problem. B is equals to 3.61 meter per second. So for problem 1.23, so you can try solving it on your own, but still I will show you the solution for that one. So for problem 1.23, it is somehow related also to problem 1.22, but this time we are going to look for vectors b1 and b2. So using again triangle method, so we have b1, so same angle 60 degree, b2 30 degree, and then we have given resultant v equals 4 meter per second. So this will be the triangle. So this is 60 degree, 30 degree, v1, v2, 4 meter per second. So if this is 60 degrees, so therefore this will be 60 degree, and this will be 30 degree, and this will be 60 degree, since 30 plus 60 is 90 degree. And if this is 30 degrees, so therefore this is also 30 degree. So using sine law, so b1 is to sine 30 equals b2 is to sine 60. equals 4 is to sine over sine 90. So our B1 will be 2 meter per second. So by computing, so I will just multiply the sine 30 to this one. So 4 over sine 90 is actually 1. It will just become 4 multiplied by sine 30. So it is 2 meter per second. So that is our B1. So for our B2, so again, it will just 4 multiplied by sine 60. So it is 3.46 meter per second. For parallelogram method, so we're just going to put our given. So V1 60 degree, V2 30 degree. So for parallelogram, we are going to create parallelogram here, and this is our V equals 4 meter per second. So it will be just like this. So the angle here, of course, will be 90 degree, and since this is a this is actually 30, 60, so therefore this is 30, so this is 30, so therefore this is 30, 60, and 90. Okay, so for the diagonal of parallelogram, this equals to a square root of a square plus b square minus 2ab cosine theta. So this is actually a cosine law. So 4 squared equals to b1 squared plus b2 squared minus 2b1 b2 cosine 90. So since we have two unknown here, so we need another equation. So I will just use this b1. So b1 squared equals to 4 squared plus b2 squared minus 2 times 4 times b2 cosine 30 degrees. So since b1, I use b1 here, so therefore the opposite angle is 30. So by just computing, so we can substitute this to this. So how is that? So 4 squared equals, our b1 squared is this equation. So 4 squared plus b squared alpha x squared minus 2 times 4 alpha x cosine 30. That is our b squared plus alpha x squared b2 squared minus 2. So what is v1? So v1 will be square root of 4 squared. So it will be square root of 4 squared plus alpha x squared and then minus 2 times 4 alpha x cosine 30. So, and then b2 alpha x cosine 90. So solving for b2, so I think it must be less than 4, so let's say 2. So our b2 will be 3.46 meter per second. So for solving b1, so we can just use this equation. So square root of 4 squared plus alpha a squared, which is the b2, minus 2 times 4 alpha a cosine 30. So that's it, 2 meter per second. Okay? So for answering using so this is b1 and b2. So answering using component method. So we need to find b1 and b2 here. So therefore we need to create two equations for this one. So looking for its x. So b1 cosine 60 plus b2 cosine 30 equals to our horizontal given velocity 4 meter per second. This will be our equation 1, and b1 sine 60 and b2 sine minus b2 sine 30 equals to 0 since we don't have any vertical given velocity. So equation 2. So using our calculator, so mode 5, 1. So we will just going to input this data. So cosine 60 equals cosine 30 4, and then sine 60 minus sine 30, 0. So we have V1, 2 meter per second, and V2, 3.46 meter per second. So that is the way how we use component method. So this is the easiest way again to solve this problem. So since it's just like problem 1.22, as we notice, this is actually a right triangle. So we can actually use using by SOHCAHTOA, which is sine theta equals opposite side over hypotenuse, cosine theta equals adjacent side over hypotenuse, tangent theta equals opposite side over adjacent side. So for this one, we are going to use cosine 60 equals adjacent side. So this is the adjacent side. And the hypotenuse, so the longest leg is 4. So the answer for B1 is 2 meter per second. And sine 60 equals to B2, which is opposite side is B2, and hypotenuse is 4 meter per second. So the answer is 3.46 meter per second. So this is actually the shortest and simplest way to solve this problem 1.23. So I just show you different methods, but this is actually the shortest and simplest way. Okay?